Okay, this is Miss Robertson, and we're going to do another example for solving trig equations. Here is an example where you're going to need the factor. Notice we have a squared term and a linear term or single term here. So we're going to look and see if there's something common that can be factored out. So really, this is hard for a lot of people to see. So you could rewrite this as x squared plus x equals 0 and factor it this way. And remember, what does x equal? X equals tangent of x. Okay, so if we're looking here, we want to look at both of these and say what's common. Well, they both have an x, so we're going to factor that common x out. When we factor it out of here, x squared divided by x is a single x. X divided by x is 1. And so we're left here. And if we were continuing to solve, we would say x equals 0 and x plus 1 equals 0. Then we would say x equals negative 1. Well, what does x equal? X equals tangent of x. So let's replace it. So we can say tangent of x equals 0 and tangent of x equals negative 1. Now we're ready to go to our unit circle and ask ourselves where on our unit circle will the tangent be 0? And so tangent is 0 when y divided by x is 0. So remember that this is y divided by x, or 0 over 1. So where is y 0? Well, y is 0 at x equals pi over 2. No, that's y 0, so that's x equals, sorry, x equals 0 and x equals pi. Okay, that's where your y is 0. So where is tangent equal to negative 1? Well, remember, we find tangent by dividing y coordinate divided by x coordinate. And so if you want negative 1, then the y and x must look the same, the only difference being the sign. So we look at our 45-degree angles, and we will see right here that if we divide these two, we get negative 1. If we divide these two, we get positive 1. If we divide these two, we get negative 1. So these are the two locations of our tangent, or where we can find tangent equaling negative 1. So we're going to use 3 pi over 4 and 7 pi over 4 for that one. So x equals 3 pi over 4 and 7 pi over 4. And so those are all the solutions that you could have around between 0 and 2 pi.